Welcome to the video lecture series Microprocessor and Microcontroller. My name is Dr. Anilesh Dey, Associate Professor, Department of Electronics and Communication Engineering, Narula Institute of Technology. This is my lecture 21. Today start with a new topic 8086 microprocessor. This is my roadmap. First we can go for the pipelining architecture, followed by feature, pin diagram, flag register, physical address generation, architecture of 8086 microprocessor, minimum and maximum mode, queue operation, memory segmentation, addressing modes, instruction sets, programming, and finally interrupt. First, this lecture I can cover up the pipelining architecture, feature and pin diagram. Next lecture I can cover the flag register, physical address generation, architecture, minimum maximum mode. After that, queue operation, memory segmentation, addressing modes in a particular lecture. Then instruction set, one lecture. Instruction and programming is a 2 lecture, and interrupt is 1 lecture. So total is a 6 lecture. I can complete it. Totals 8086 microprocessor. First, I could go for the pipelining architecture. Now recall the 8085 microprocessor. In 8085 microprocessor, if I execute one instruction, I just followed the 3 steps. One is called the fetch, one is called the decode, and finally is the execution. So after completion of the 3 steps, one instruction is executed. So total time taking the execution of that particular instruction is the time for the fetch one, time for the decode one, and time for the execution one. So if E stands for fetch, D stands for decode, E stands for the execute. So this is the total time taken to execute 2 instructions through 8085 microprocessor. Fetch 1, decode 1, execution 1 for the first instruction, F2, D2, E2 for the second instruction. Now 8086, the architecture is divided into 2 parts. One is called the BIU, bus interface unit. One is called the EU, execution unit. The combination of this thing is a 8086. Bus interface unit is responsible for the fetch the instruction, and execution unit, it is responsible for decode and execution of the instruction. Now first, when the first instruction in 8086 is fetched, and after that it will send to the execution unit for the decode and execute. At that same time, the next instruction is fetched. When the next instruction is going for the decode and execute in the execution unit, the third instruction F3 is fetched. Now I can take, this is the total time taken to execute the 2 instructions through 8086 microprocessor. So from this diagram, it is clearly understandable by this portion, the time is saved in 8086 microprocessor. So I can say that through the pipelining architecture, it is clearly understandable that 8086 microprocessor is faster than 8085 microprocessor, because that BIU and EU doing the separate task, and when the EU doing their task, BIU start the operation for the next instruction. So this is called the pipelining architecture in 8086 microprocessor. Now I'll explain what is the feature of 8086 microprocessor. It is a 16-bit processor. So if there is a 16-bit processor, obviously the data bus is a 16. So address bus is a 20-bit, data bus locate the memory location, maximum size of the memory that address bus can access, that is nothing but the 2 to the power 20. I already told in the 8085 that it is a thumb rule. Anything in the command in the digital one domain, it is a power of 2. So address bus is 20, so maximum size of the memory which can 8086 access, that is a 2 to the power 20. This is the starting address. If it is a 20-bit address bus, so that is a starting address 00000H and ended with the FFFFFH. So this is the address. Data bus is 16. Already I told that if it is a 16-bit processor, so obviously data bus should be 16. ATS is classified into the three types, and we can classify it with the help of the clock frequency. Rather, we can say in the market three type of 8086 available. One is the 8086, that is a simple 8086, that is a clock frequency 5 megahertz. Then 8086 one clock frequency is a 10 megahertz. When 8086 2, it is a 8 megahertz. This is the basic features of 8086 microprocessor, and I will go for the pin diagram. These are the basic pin diagram of a particular 8086 chip. This is the 40 pins IC. But here it is clearly identified that here this pin is used for a mode operation is called the minimum mode, and this pin is used for the operation for the maximum mode. So one pin is there, pin number 13, that is a min/max bar is there. When this pin is 1, 8086 work in the minimum mode. When this pin is 0, x86 work in the maximum mode. So this pin, this total pin, I can explain when I discuss the minimum and maximum mode of 8086. Rest of the pin, this 1 to 20 pin, these pins, and these are the pins I can explain in this particular lecture. Now first, I can go for the 80 to 87. It is the address, multiplex address data lines. The address and database separated by use the ALE signal, similar just like the 8085. AD15 to AD8 address database line compose the upper multiplex address databus. This line contains the address bit A8 to A15 and databus D8 to D15. The address database are separated using ALE signals. A19, S6, A18, S3. Address status bits are multiplexed to provide the address signal A19 to A16 and also status signal S3 to S6. The address bits are separated from the status bit using the ALE signal, and status bit S6 is always logic 0. Bit S5 indicate the condition of the interrupt flag bit. S4 and S3 being used to memory access indicates which segment registers is presently used. So I can take the if S3 and S4, there is a 2 bit, so there is a 4 combination are there. When these bits are 00, it select the extra segment register. When it is a 01, it is access the stack segment register. When it is a 10, it is a code segment register, and when it is a 11, it is a data segment register. So in 8086 microprocessor, there is a segment registers are there. All the segment registers are 16-bit, and it is being accessed with a combination of the S3 and S4. Now BHE bar S7. The bus high enable BHE signal is used to indicate the transfer of the data over the higher order data bus. It goes low for the data transfer over the D8 to D15 and is used to derive the chip select of odd address memory bank for peripherals. Now, if this is the BHE bar A0, there is a 2 bits. So there is a 4 combination 0001 1011. So when it is 00, it is accessing the whole word. When it is 01, it is accessing the upper byte from odd to odd address. When it is 10, lower byte from odd to even address, and 11, it is ignored or done. Ready pin. This pin is acknowledgement for the slow device of the memory, so that they can use during the data transfer operation. This signal is active high. Test bar. This is the input is tested by the wait instruction. If the test inputs low, execution will continue. Else, the processor remains in an ideal state. So this is a very important pin. Several times it is asked in the examination. NMI, non-maskable interrupt. The non-maskable interrupt input is similar to the INTR, except that the NMI interrupt does not check the interrupt enable flag is at logic 1. That is, NMI is non-maskable initially by software. If NMI is activated, the interrupt input use the interrupt vector 2. So this NMI stands for the non-maskable interrupt. If it is a one flag NMI interrupt does not check the interrupt enable flag whether it is the logic 1. Reset. The reset input causes the microprocessor to reset itself. When 8086 reset, it restart the execution from the memory location FFFF0H. The reset signal is active high and must be active for at least 4 clock cycle. Clock input. Clock input signal provides the basic timing input signal for the processor and the bus control operation. It is asymmetric square wave with 33% duty cycle. VCC plus 5 volts power supply for operation the internal circuit, and ground for the internal circuit. Now it is observed that in 8086 two ground pins are there. These 2 ground ports are used for the load balancing of the total circuit operation. That's why there is a 2 ground pins are there. So this is the basic pins of the 8086. I'm escaping some pin which is used for the minimum and maximum mode, and pin number 33 I am also escaping in this lecture. But next lecture, when I go for the minimum and maximum mode, I can explain that each and every instruction, every pin which is used for the minimum mode and maximum mode in 8086 microprocessor. So this is up to the today's lecture. This is my contact details. So this is the end of lecture 1, and between lecture 21 and between lecture 22. So if you like, then please subscribe my YouTube channel.